So, last class we have derived that plane wave equation, which is we have derived that plane wave equation, divergence square of pressure, acoustic pressure is nothing but a 1 by c square del square d square, or this can write del square p by del t square. This is the plane wave linear wave equation, we call linear wave equation. Now, interesting property we should know, that we know that velocity, we said called the velocity potential. What is velocity potential? The interesting thing is that if you know that the curl of a gradient function, any function, if I take the gradient of the function and then take the curl is equal to 0, that is the mathematical proof. The curl of a gradient function is equal to 0. Now, if you remember that we have derived that equation where the particle velocity rho 0 del u by del t is equal to minus p, that we derived rho 0 del u by del t is equal to minus divergence of acoustic pressure. Now, if I take the curl in both sides, so I take the curl in both sides, then I said curl of a divergent function is equal to 0. So, that means this is equal to 0. Okay. So, if it is this equal to 0, that this implies that the curl of u velocity, curl of particle velocity is equal to 0. So, if the particle velocity is u and that curl is equal to 0, what is the meaning, physical meaning of this thing? What is curl of a velocity? Curl of a velocity means that particle velocity does not have any angular motion. There is no curl. If you know that, what is the divergent? Divergent means how it is diverted. What is the curl? Curl is the rotational things. So, curl of u is equal to 0. That means we are considering in linear wave equation there is a no particle velocity in angular direction. So, there is a no angular velocity in the particle velocity, only the linear velocity exists in particle velocity. So, if I say the particle velocity is nothing but it can be expressed in a scalar function. So, I said u is nothing but a divergent of phi, because particle velocity is in all direction, but it does not have any angular motion. So, the u is nothing but a divergent of a scalar function. This phi is called velocity potential. This phi is called velocity potential. Okay. Now, if u is equal to divergent of phi, then what should be my equation? My equation is then rho 0. So, what is there? So, rho 0 del u by del t is equal to minus p. So, it is nothing but a rho 0 del u by del t plus divergence of acoustic pressure is equal to 0. Okay. So, what is rho 0? So, if I say that I can take the divergent out, or I can say that what is u? U is nothing but a divergence of velocity potential. So, I put it rho 0 del divergent phi del t plus divergent p is equal to 0. Okay. So, in that case, if I take the divergent out, it is nothing but a rho 0 del phi by del t plus p is equal to 0. If this function is equal to 0, divergent of a some function is equal to the 0, that means that rho 0 del phi by del t plus p is equal to 0. Okay. So, rho 0 del phi by del t is equal to minus p. So, the velocity potential rho 0 del phi by del t is equal to minus p. This will be used in wave equation. That is why I said the phi is the velocity potential, and that will be is equal to del rho 0 del phi by del t is equal to minus p. Now, what is C? If you see that velocity of the sound, is it depends on temperature? Velocity of sound, how it is dependency of the velocity of sound. So, I say bulk modulus B is equal to rho 0 del P by del rho at rho 0. Okay. So, it is nothing but a gamma P 0 total pressure is nothing but a rho 0 C square. Okay. So, what is C square? C square is nothing but a gamma P 0 divided by rho 0. Okay. Now, you know the P is equal to, what is P is equal to? Rho R T K, gas equation, from the gas equation. R is the gas constant, rho is the density, T is the temperature in Kelvin. Okay. So, if you see, sorry, okay. So, now in that case, so if I see that, if I put the P value in here, so it is nothing but a gamma rho 0 R T divided by rho 0. So, it is nothing but a gamma R T. Now, in case of T, so T depending on the T, C is varies. So, the velocity of the sound depends on the temperature. If the temperature change, velocity of the sound will be changed. Now, we go further. So, we have derived the linear wave equation, we have know that velocity potential, we know the sound, the speed of the sound is changed with temperature. Then, we have to know how that plane wave is propagated in the medium. So, that is called harmonic plane wave, harmonic plane wave. How the plane wave is propagated in the medium? We know the equation, but how it is propagated, that we have to describe. So, now we go for harmonic plane wave propagation. How to find out what should be the equation of the P if it is propagated in a media. So, now we have derived the equation of P and U, and we have described how the harmonic plane wave is propagated in a medium. In harmonic plane wave, the characteristics of the harmonic plane wave is that a plane wave is that each acoustic variable has a constant amplitude and phase on any plane perpendicular to the direction of the propagation. What is the meaning? If I say the wave is propagated along the x axis, so perpendicular to the x axis, let us the z axis. So, in the z axis, all the acoustics variable of that plane wave are constant amplitude. So, that is the meaning. That means, if the wave is propagated along the x axis, perpendicular to the x axis is the z axis. So, in the z axis, all the acoustic properties, all the acoustic variable of that plane wave will be remain constant. So, practical example is that if you throw a stone in a pond, you find there is a wave is generated. Let the what is the wave propagation? Propagation is along the plane of the water and towards the end of that towards the land. So, the wave is propagated like this way. Okay. Now, what is the perpendicular that the wave? Perpendicular is the z direction. So, in perpendicular direction at any point the acoustics variable of all that exist in that propagation wave have a constant amplitude. That is the properties of plane wave. Now, we know that what is the plane wave equation? We know del square P is nothing but a 1 by c square del square P by del t square. Okay. So, this is the plane wave equation. So, this is a second order differential equation where P is a function of x, y, z and t. So, that means P is a function of position and time. So, when a plane wave is propagated, it is free to propagate it in any direction. In that, suppose this room I create an acoustic sound. So, this sound can propagate in any direction of this room. So if it is any direction, so it is x, y and z, any direction it can propagate, and once it propagates, it has to be respect to the time. Okay. So the pressure wave has a function of x, y, z and t. Let's my propagation, the plane wave propagated along the x axis only. There is no propagation in z and y axis. So if the plane wave propagated along the x axis only, so p is a function of x and t only. P is a function of x and t only. So in that case, this becomes del square p by del x square is equal to 1 by c square del square p by del t square. So this is a second order differential equation. Now what is the solution of the differential equation? I have to find out the solution of the differential equation. What is the solution? The solution will be in the form of p is equal to a e to the power, you know that second order differential equation, the solution will be e to the power j omega t minus kx plus b e to the power j omega t plus kx. Okay. So here one solution is omega t minus kx, another is omega t plus kx. What is the meaning of this thing? Meaning is that when a wave is propagated, there is a called forward wave and there is a called backward wave. So it is forward wave. So along the x axis, if it is forward wave, then I write minus kx. If it is backward wave, I write plus kx. What is k? K is nothing but a wave number. So what is the wave number? Wave number is nothing but a omega by c. C is the velocity of the sound, omega is the frequency. Okay. So wave number into x is the total distance travelled by the wave. Wave number into x, total distance travelled by the x. So if it is a forward wave, then it is plus, a minus. If it is a backward wave, then it is plus. So distance, forward wave means distance is covered, and backward means distance to be covered. So that's why minus kx plus kx. So one is forward wave, another is backward wave, and k is the wave number, omega by c. So c is the velocity of the sound, omega is the frequency of the sound. Now you know that one of the equation of the wave is, so this is the p. Now what I have to know? If this is my p, what is u? I have to derive particle velocity. If this is the pressure wave equation, then what is the equation of the velocity wave? So if I say that this is the p, then what is the relation of the p and u? Rho 0 del u by del t is equal to minus divergence of p, minus divergence of p. Now you know del by del t is we use as a, this is written as a j omega, because that sound, entire sound field is varying with the e to the power j omega t. So what is the d by dt is nothing but a j omega, because if I take the derivative, it only creates the j omega. So this convention I will use many of the cases. So differentiation means it has to multiply by the j omega. So in that case, if I write, so this is nothing but a, since I have only x direction, so this is divergence means I have only x direction, so it is dp by dx, and it is nothing but a u into j omega, d by dt is j omega. So it is rho 0 u j omega is equal to minus dp by dx. So what is dp by dx? If this is p, what is dp by dx? Differentiation against x. So it is nothing but a j k minus e to the power j omega t minus kx plus b j k e to the power j omega t plus kx. Okay or not? I take the simple differentiation of this equation. So now I put this value in here. So actually u is nothing but a 1 by rho 0 j omega into this function. So it is minus a j, so that will be minus sign is there. So minus this into a j k e to the power j omega t minus kx plus b j k e to the power j omega t plus kx. Okay. Now what is k? K is nothing but a omega by c. So instead of k, I will write omega by c. Instead of k, I will write omega by c. Now j will be cancelled. All j will be cancelled. So it is nothing but a minus plus. So it is a omega will be cancelled. So a by rho c. Omega and omega will be cancelled. Minus a plus a by rho c e to the power j omega t minus kx plus b by same rho c. This will be not plus, this will be minus, because this minus will be created minus b by rho c e to the power j omega t plus kx. Okay. So that means u is nothing but a 1 by rho c if I take out. So it is nothing but a e to the power j omega t minus kx minus b e to the power j omega t plus kx. Okay. So by 1 by rho c. So if I know the p, I know the u. So this is the u. Now forget about s. What is phi? Phi is the velocity potential. I said phi is the velocity potential. So rho 0 del phi by del t is equal to p minus p. Okay. So phi is nothing but a rho 0 j omega phi is equal to minus p. So phi is minus p by j omega rho 0 and p is plus minus. I am writing p is plus minus. Instead of forward wave, backward wave, I write plus minus. Plus means backward wave, minus means forward wave, plus minus. So it is nothing but a phi is plus p by j omega rho 0. Okay. So this is the relation between the u, phi and p. Those will be used in deriving that solution. Now what is the plane wave equation? This is the plane wave equation. Okay. Now in case of arbitrary direction, if I consider the plane wave propagated in arbitrary direction, in that case the solution of p will be not in only x direction. So it is x, y and z direction. So it is nothing but a e to the power j omega t minus kx into x minus ky into y minus kz into z. So I am saying the arbitrary direction is wave is propagated. Okay. So that the solution will be a only this one, forward, backward, x direction, y direction, z direction, all arbitrary direction is propagated. So it is e to the power j omega t minus kxx plus minus kyy minus kzz. Okay. So this is the propagation equation. P is equal to this only. Now if I put this solution in this equation, what I will get? I put this solution in this equation. So p, what do you mean by del square p? Is nothing but a d2p by dx square plus d2p by dy square plus d2p by dz square. Okay. If I take this, I will get omega by c whole square is nothing but a kx square, sorry, এটা রেখে দিন তো, kx square plus ky square plus kz square. Okay. So, I said that if I put this a value in this equation, I will get omega by c whole square is equal to kx square, ky square, kz square. That means as if kx square plus ky square plus kz square root over is equal to nothing but a omega by c. Okay. So, if I consider, I have an wave, I have an acoustics wave and whose propagation vector. So, I have an acoustics wave in all three directions. Okay, all three directions. This is y direction, this is x direction, this is z direction. So, the wave is propagated in this field. So, I have a three direction, y direction and xy plane, x direction and y direction. Okay. So, a propagation vector is here, which is k. Okay. So, in propagation vector has an amplitude, as if in this room I have a point in here. So, from one corner, if this corner is origin to here has an amplitude and has an angle with x axis, y axis and z axis. So, propagation vector this k has an angle with z axis, has an angle with y axis, has an angle with x axis. Okay. So, if I put that, if I put this thing, so I have an angle with z axis, I have an angle with x axis, this has an angle with y axis. So, that three axis I have an angle. So, the angles are beta, alpha, gamma. Okay. So, what is the amplitude of k? Amplitude is nothing but a root over of kx square plus ky square plus kz square. Those are the point. Distance from z axis is kz. If I take a projection in here, so distance from this point in here is kx and here is ky. Okay. So, amplitude is this is nothing but a omega by c, we have already proved. So, it has an amplitude and has a position x, y, z. So, I can write the point k is nothing but an amplitude k and a position vector r, r is the position vector. Okay. So, r has a position vector. So, r has an x position, x direction, x position, y direction, y position, if x, y, z and z direction, z position. Okay. So, amplitude, anyway, this is the coordinating system, this is the representation, amplitude and the position is the k, is written like that way. So, I can write that instead of e to the power minus kx, ky, kz, I can write p is nothing but a e to the power j omega t minus k into r, kx, x, ky, y. So, that has a position k which is omega by c, this is amplitude is k is nothing but omega by c into r is a position vector. I write amplitude and position vector. Okay. Now, what is r? If I said that k has an angle with x axis, alpha. So, I can write what is cos alpha, nothing but a kx by k. If I have a trigonometric system, if the angle is alpha, this is k and this is kx. So, cos alpha is nothing but a kx by k. Similarly, cos beta is nothing but a ky by k. Cos gamma is nothing but a kz by k. Okay. So, I can write instead of kx, ky, kz. So, I can write mod amplitude, mod k is the amplitude. So, it is nothing but a root over of x square plus kx square, z square. So, it is nothing but a k into cos square alpha. So it is k into k square alpha plus k square cos square beta plus k square sin square cos square gamma. Okay, so it is nothing but a k into root over of cos square alpha, cos square beta, cos square gamma. Okay, so now if I say k into r is the wave vector. Vector directional this is called propagation vector. So this propagation vector is equal to constant. Characteristics of the plane wave says that perpendicular direction to the propagation is nothing but a constant phase. So k into r is constant. So if it is constant, then let us consider a situation where let us say my plane wave surface is parallel to z axis. Surface of the plane wave is parallel to the z axis. That means the plane wave is propagated along the xy plane. So if we throw a stone to the pond, so a whole water level is the xy plane. XY plane. How it is propagated? The surface constant of that wave is perpendicular to the z axis. So if this is the pond, water level, then the wave propagation is a perpendicular. The surface constant of that wave is perpendicular to the xy plane. So it is nothing but a parallel to z axis. So let us plane wave whose surface constant are parallel to z axis, that constant. So that means plane wave is propagated along the xy plane. So there is no propagation in z direction. So in that case, P is nothing but a e to the power j omega t minus kxx minus kyy. Z direction there is no propagation. Okay. So parallel to the z axis, surface constant is parallel to the z axis. Okay. Now in that case, what is this is kxx kyy. Okay. So I said that k dot r should be a constant. So that means minus kxx or kxx plus kyy, which is nothing but a k dot r propagation vector is equal to constant, okay, constant. So in that case, what is kyy is nothing but a minus kxx plus constant. Let us see. So it is nothing but a y is nothing but a minus kx by ky into x plus c. See the equation, y equal to mx plus c is the equation of a straight line. What is m? M is nothing but a tangent, that is the oblique angle on the xy plane. Angle. So if I have this equation, that means if I have a straight line like this, so this is the angle is m. M is represent the angle, slope. So in that case, I can write that wave is propagated along the xy plane with the angle kx by ky. So wave is propagated in real life situation. If I throw a stone to the pond, wave is propagated like this xy. This is the xy plane. Okay, but it is not necessary that without any angle. Wave is propagated in that xy plane with the angle which is defined by kx by ky, and wave surface is always, if I cut the wave surface is always perpendicular to the z axis. We said, so wave is propagated along the xy plane with the angle kx by ky. So now if I draw the pictures, I cannot draw the three-dimensional pictures. This is my xy plane. This plane is this board, this blackboard is an xy plane. So, this is x axis, this is y axis. So, this plane is xy plane. So, wave is propagated along the xy plane, okay, with the angle which is defined by, so this is the wave propagation, this is the wave propagation with the angle which is phi. Phi is not, tan phi is nothing but a minus kx by ky, okay. So, with the angle phi, so I can write that this cos phi is nothing but a, what is cos phi? Cos phi is or I can write kx is nothing but a k cos phi, this angle phi. So, this x axis projection is k cos phi, and what is y axis projection? Ky is nothing but a k sin phi, okay. So, whole k can be written as k is nothing but a k cos phi in x direction plus k sin phi in y direction, okay. So, if what is the equation of this plane wave equation? So, it is nothing but a p is equal to a e to the power j omega t minus k cos phi x direction, k cos phi x direction minus k sin phi y direction. So, I get the equation of propagation, okay. So, that way we can derive the plane wave propagation equation. It may be xy plane, it may be yz plane. So, in that case of yz plane, x will be not there. So, we are discussing about the plane wave propagation and we derive the expression of the plane wave propagation equation, okay. Now, we have to know how calculate the energy of the plane wave propagation, okay. So, energy for the plane wave propagations. So, you know that, let us consider that a plane wave propagated along the x axis, okay. So, along the x axis. So, propagation pressure equation P is equal to pressure amplitude e to the power j omega t minus kx. This is the propagation pressure equation, okay. Now, for that, so we have to derive that energy. Now, if I consider how the plane wave is propagated, now if when a wave is propagated, it is nothing but a when the pressure wave is propagated through a media, how the energy is transferred. So, let us consider a small volume on the propagation field V0, V, which is V0, okay. So, you know that it is compressed and decompressed. So, the energy, so when the wave is propagated, this volume will be compressed and the volume will be expand, okay. So, any compression and expansion has a potential energy, okay. So, that creates the potential energy which is Ek, Ep. Similarly, when the wave is propagated through a media, the particle has a velocity. So, that creates an kinetic energy Ek. So, the total energy in a plane wave propagation E is nothing but a kinetic energy plus potential energy, okay. Now, we have to derive the expression for the kinetic energy and potential energy. Now, if you know that what is kinetic energy Ek? If the volume velocity is u, if the particle velocity is u, then or volume velocity is u, then kinetic energy is nothing but a half m v square, half u square, okay. Now, if I consider that small volume V0 on that propagation plane, that this is the small volume V0. So, V0 will be compressed. If it is compressed, some potential energy will be stored. If it is decompressed, potential energy will be released. So, this is the kinetic energy. So, the potential energy Ep is nothing but a change of volume. Let us that where it is V0 is initial volume V0 to V. Change of volume due to the pressure applied on that volume P, Tv, and this is negative sign indicate that the energy is if the volume is compressed, then the force is acting on that volume. The pressure divided by pressure into unit area is the force, cross sectional area. So, force is acting on the volume and volume is decreased. So, the decrease, even the force is increased, the volume is decreased. So, direction of the if the F is increased, then volume decreased. So, what will happen? So, potential energy will be increased when the volume is decreased. So, that is why I create a negative sign, that change of volume and applied force is in reverse. Okay. So, that is why I create a negative, I give a negative sound. So, due to the change of volume, the potential energy will be created. So, if you see the slide also, the negative sign indicate that the potential energy will be increased when its volume is decreased by positive acoustic pressure P. Okay. So, now, if you remember, the PV, rho V, rho into V is what? Is nothing but a mass. So, rho V is nothing but a constant. Rho V is constant, mass is constant. Now, if I take the derivative with respect to d and V, so I can write rho into del V plus V into del rho. Rho into del V plus V into del rho is equal to 0. Okay. So, from here another equation is bulk modulus B is nothing but a rho 0 del P divided by del rho. This is the bulk modulus, which is nothing but a B by rho 0. C, velocity of the sound, C is nothing but a root over of bulk modulus B divided by rho. So, I can say C square is nothing but a B square by rho 0, B by rho 0. So, B by rho 0 is nothing but a C square. So, I can write that del P by del rho is nothing but a C square. Okay. Now, if I say, if I put that, so I can say that del V is equal to what? Del V is equal to minus B del rho divided by rho, del rho divided by rho. So, del rho, here I can write del rho is nothing but a 1 by C square into del P. So, I can write this is nothing but a minus V del P divided by rho 0 rho C square. Rho C square. So, I put that things in here, this equation. So, it is minus positive. So, del V, I putting the value of del V is on these things. So, positive minus and minus positive. So, it is plus. So, it is nothing but a, if it is V0 to V, then if I convert to del P by del C square, so it will be 0 to P pressure. So, 0 to P into V del P by rho C square. So, which is nothing but a half of P square by rho 0 C square into V 0. Okay. So, if it is that, then what is the total energy? So, total energy is nothing but a kinetic energy plus potential energy. So, energy is equal to half mu square plus half P square by rho 0 C square V 0. Rho 0 C square V 0. Now, what is m? M is nothing but a rho 0 into V 0 small volume, mass of that volume is rho 0 into V 0. So, it is half rho 0 into V 0 into u square plus half rho P square by rho 0 C square into V 0. So, I can say E by V 0 is nothing but a half, let us rho 0 is take this side. Okay. So, it is nothing but a U square plus P square by rho square C square. U square by U square plus P square by rho square C square. Okay. So, this is the E by V 0. What is E by V 0? Is nothing but a energy density, instantaneous energy density EI. E by V 0 is instantaneous, this is the instantaneous energy. So, energy divided by the volume is nothing but instantaneous energy density, and its unit will be joule per meter cube. Okay. Now, we are not taking the instantaneous energy density, we always take the average energy density. So, what is average energy density? I can write average energy density E is nothing but a time average of instantaneous energy density. Okay. So, time average of instantaneous energy density. So, this is nothing but a 1 by T 0 to T EI dt. Okay. So, what is EI? EI is nothing but a U square plus P square by rho square C square. Okay. So, is U square plus P square by rho square C square. Now, take some consideration. What is relation between the U P? You know the P is nothing but a plus minus rho C into U. Pressure is nothing but a plus minus rho 0 C into U. Okay. Now, if I say the pressure equation P is nothing as a pressure amplitude P plus cos omega t minus kx, then what is U? Is nothing but a pressure amplitude P by rho 0 C cos omega t minus kx. Okay. Now, if I put the two value in here, either I can convert either in term of P or in term of U. So, let us consider in term of P. So, it is U square is nothing but a P square by rho square C square. So, it is nothing but a, if I put that value, so it is nothing but a P square plus K 2 will cancel. So, it is nothing but a P square by rho 0 C square. So, I put the value in here. So, the 1 by T 0 to T P square. So, P square means P square by rho 0 C square. So, it is which is nothing but a 1 by T 0 to T pressure amplitude square cos square omega t dt, cos square omega t minus kx divided by rho 0 C square dt. Okay. Which will be, if I take the integration, it will be P square by 2 rho 0 C square, P square by 2 rho 0 C square. So, if it is P square by 2 rho 0 C square is the average energy density, still we are not getting the energy, power and intensity. So, what is energy? This is the average energy density E. Now, let us consider that the wave is propagated along this blackboard. So, let us consider a volume with a cross sectional area A. Okay. So, energy density inside the, let's consider a pipe. Okay. So, you are saying that energy density inside the pipe is nothing but a p square by 2 rho c square. So, how much energy will be flow in 1 second? So, energy density, if it is energy density is known, then if I multiply the volume of that pipe for 1 second pipe volume, then I can get that energy, total energy. So, let us for dt time, if the velocity of the sound is c, so length of the pipe will be c into dt. Within the dt time, c into dt length will be covered, and if the cross sectional area is a, then the volume is a c dt. Okay. And total energy E is nothing but a energy, average energy multiplied by that volume is the total energy. So, what is power? Power is nothing but a energy per unit time. So, energy by dt. So, power is nothing but a E A into C. Have you understand not? See that this board also, these slides. So, I am saying I want to find out the energy flow, okay, for that plane wave propagation. So, I find out the expression of the energy density, which is p square by 2 rho 0 c. Now, if I know the energy density, let us I consider for the dt time how much energy will be flow within this volume, which cross sectional area is A. So, it is nothing but a c dt into A. So, energy density multiplied by the volume is nothing but a total energy, energy by volume. So, volume by multiplied. Now, if I get the total energy, what is the power? Energy per unit time. So, energy divided by dt. So, it is nothing but a E into AC. Okay. So, it is not capital E, small e, E into average energy density multiplied by A into C. Now, what is intensity? Intensity means the power per unit area. So, intensity I is nothing but a P by A. So, if it is P by A, then intensity is nothing but a E A C divided by A. So, A cancel, it is E into C. So, what is E value? P square by 2 rho C square. So, P square by 2 rho 0 C square into C. So, it is nothing but a P square by 2 rho 0 C. So, intensity of the plane wave propagation is nothing but a P square by 2 rho 0 C, P square by 2 rho 0 C. So, intensity, if I consider for the plane wave propagation of the sound, then always if I know the sound pressure, then intensity of the sound is nothing but a P square by 2 rho C, and power intensity multiplied by the area. So, that is the power. So, P square by 2 rho C is the intensity. Okay. Next, we discuss about the spherical wave propagation, and then we consider the how intensity will be calculated for the spherical wave propagation, and what is the difference between the plane wave propagation, then intensity in dB, then perception of the sound in dB, perception of the sound we will talk about, and then we complete this chapter. Okay.